In today's video, I'm going to teach you how to create a correlation matrix in Python. A correlation matrix is a compact way to see how pairs of numeric variables move together, from strongly negative to strongly positive. It's great for quickly spotting relationships, multicollinearity, or redundant features before modeling. First, make sure you have the right libraries installed. We'll use pandas for data handling, seaborn for visualization, and matplotlib to display the plot. Open your terminal or command prompt and run. Pip install pandas seaborn matplotlib. If you're on a system where Python 3 is the default, pip3 install works the same way. It's also a good idea to do this inside a virtual environment so your project dependencies stay clean. Next, import them into your Python script or notebook. At the top, write import pandas as PD, import seaborn as SNS, and from matplotlib, import pyplot as plt. If you like a consistent look for your plots, you can also set a style with sns.set. Now you need a pandas data frame with numeric columns. You can load your data from a CSV file using pd.read csv your file.csv, or create a small example data frame from a dictionary if you're just testing. The correlation matrix only makes sense for numeric data, so if your dataset has text columns, either drop them or select only the numeric columns with something like df.select d types include number. If you have missing values, consider handling them first by dropping rows or filling them, since nans can lead to incomplete results. To compute the correlation matrix, call the corr method on your data frame, corr equals df.corr. By default, this uses the Pearson correlation, which measures linear relationships. Values range from 1 to 1, where numbers near 1 indicate a strong positive relationship, numbers near 1 indicate a strong negative relationship, and numbers near 0 suggest little to no linear relationship. If your data is ordinal or not linear, you can pass a different method like Spearman or Kendall to corr for a rank-based view, but Pearson is a solid default. A raw correlation table can be hard to scan, so let's visualize it with a seaborn heatmap. Create a figure, then call sns.heatmap corr anot true cmap coolwarm vminchoutum1 vmax1 square true. Adding anot true prints the correlation values in each cell, and fixing the color scale from 1 to 1 keeps colors consistent. Finish with plt.title, correlation matrix, and plt.show. If the labels overlap, increase the figure size or rotate the tick labels for readability. For large matrices, you can hide annotations or mask the upper triangle to focus on unique pairs. That's it. You've loaded your data, computed correlations, and visualized them clearly in Python.